Let's try solving a second-order integrated rate law equation. In this case, butadiene C4H6 dimerizes to form C8H12 by the reaction shown here. We're given the rate is K times the concentration of C4H6. And in this case, we're told that it is raised to the second power. This is another way to tell us that it is a second-order reaction. So we need to calculate the minutes for C4H6 concentration to fall from 0.2 molar to 0.114 molar. So we have a concentration of A0 and we have a concentration of AT. And we have a value of K equal to 0.92. We're going to be using the equation in yellow. So we have 1 over AT minus 1 over A initial is equal to 0.92 times time, and we're going to be solving for time. So we substitute our concentrations. So we have 1 over 0.114 minus 1 over 0.200, and that is going to be equal to 0.92 times T. We solve for T, and T is going to be equal to approximately equal to 4.1 minutes. Let's put a little box around it to show that we're done. Okay, here's another type of problem that you might encounter. It says if the initial concentration of the C4H6 is 0.12 molar, what is the concentration in 3 minutes? So we're solving for AT in this case. We have the initial concentration. And this is equal to 0.92, which is our value of K, times 3.0. In other words, 1 over AT is going to be equal to 0.92 times 3.0 plus 1 over 0.120. And you'll find that AT is going to be equal to 0.0901 molar. And we put a box around it to show we're done. Our last problem asks, what is the instantaneous rate of reaction when the butadiene has a concentration of 0.85 molar? So really what this is saying is that we're going to be solving for rate equals K, and whatever the concentration of A is, squared. So it's just a matter of realizing that when they're talking about the instantaneous rate, you're going to be using the rate equation. So rate is equal to 0.92, which you have from earlier, and you're given 0.85, and you're going to square it. And when you do that, you get 0.00665 moles, liters -1, minutes -1. And there's your final answer.